Pelton wheel, Pelton turbine. Pelton wheel is a tangential flow impulse turbine used for high heads and small quantity of water flow. The Pelton wheel extracts energy from the impulse of moving water as opposed to water's dead weight like the traditional overshot water wheel. It consists mainly of Pelton turbine penstock, runner, brake nozzle, bucket, spare, casing. The Pelton wheel consists of the following parts: A. Nozzle with a spear head. B. Runner and buckets. C. Turbine casing. First, nozzle with a spear head. A nozzle is a passage of varying cross-section attached to the penstock. The nozzles may vary in number depending on the design requirements. Usually nozzles are arranged around the runner wheel such that the water jet emerging from a nozzle is tangential to the circumference of the runner wheel. The flow of water through the nozzle is controlled by a spearhead, which is operated by means of a hand wheel. This arrangement provides a smooth flow of water with negligible energy losses. The amount of energy available from water depends on both the quantity of water available and its pressure. The pressure is referred to as the head, which is defined as the vertical height in meters or feet from the level of water in the dam, river, to the level where the water leaves the turbine housing. The greater the flow and head, the more electricity produced. A runner is a circular wheel with a series of evenly spaced blades fixed around its periphery. Next, runner and buckets. The runner is a circular wheel with a series of evenly spaced buckets fixed around its periphery. The buckets, cup-shaped blades, are shaped like a bowl or a double hemispherical cup. The advantage of having double cup-shaped buckets is that the jet of water gets split and leaves symmetrically on both sides of the buckets. This helps to eliminate the end thrust or axial thrust on the bearing and the output shaft. The flow of water on the bucket. The runner is coupled to a rotating shaft. Next, turbine casing. The casing prevents the splashing of water, and it also helps to discharge the water into the tail race. The whole arrangement of runner and buckets, inlet and braking jets are covered by the casing. Casing of Pelton turbine does not perform any hydraulic actions but prevents the splashing of water while working and also helps the water to discharge to the tail race. Next, the working of Pelton turbine. In operation, water from the reservoir, dam, having potential energy, flows through the penstock and enters the nozzle. As water flows through the nozzle, the potential energy of water is completely converted into kinetic energy in the nozzle. The high-velocity jet of water issuing fiven, the nozzle impinges on the curved blades fixed around the runner wheel. The impulse force due to the high-velocity jet of water sets the runner wheel into rotary motion. Hence, the shaft, coupled to the runner wheel, also rotates, thereby doing useful work. After performing work, the water freely discharges to the tail race. The work produced at the output shaft is used to drive a generator to produce electricity. The electricity is then transmitted to a substation where transformers increase voltage to allow transmission to homes, office, and factories.